derive a relation between the internal resistance, EMF, and terminal potential difference of a cell from which current I is drawn. Draw V versus I graph for a cell and expand its significance. Okay, coming to the first part here, relation between the internal resistance, EMF, and the terminal potential difference. We require a circuit, that is, this is the junction A and B, and this is the resistance R, and this is the battery connected with the slot and R, and the current is flowing in this direction. Okay, now with this one, we know that E minus I into R minus Ri is equal to 0. Then if I'm going to take E minus I into R is equal to V minus IR is equal to 0. Then E is equal to V plus IR. This is the relation between the internal resistance, EMF, and terminal potential. Next, draw V versus I graph. That means this is the V versus I graph. If the current I is increases, the voltage is gradually decreases. Okay, coming to the significance. To find the CMF and internal resistance of the cell, we required this graph. Coming to the part B question, a voltmeter of resistance 998 ohms is connected across a cell of EMF 2 volts and internal resistance 2 ohms. Find the potential difference across the voltmeter and also across the terminal of the cell. Estimate the percentage error in the reading of the voltmeter. Okay, so this is a voltmeter. Everything it is connected here. Now we know that V is equal to I minus E minus IR. We know that V is equal to E minus I times R. Okay, then substitute the values. It is 998 times I is equal to 2 minus 2I. If minus 2I will come to this side, then this becomes plus. That is 1000I is equal to 2. Then I is equal to 2 divided by 1000, which is equal to 0.002 amperes. Okay, then V is equal to 0.002 into 998, which is equal to 1.996 volts. Coming to the percentage error, which is equal to 0.004 divided by 2, that into 100, find percentage multiplied by 100, we'll get the value, that is 20%. 20% is the error. Two cells of different EMFs and internal resistance are connected in parallel with one another. Derive the expression for the equivalent EMF and equivalent internal resistance of the combination. Okay, so if you see this circuit, this is the two circuits are connected in the parallel. Then we know that I is equal to I1 plus I2. Then we need to find here the term, that is V is equal to, that is a potential difference across B1 and B2. B1 and B2 across this, the potential difference is V is equal to E1 minus I1 R1. V is equal to E1 minus I1 R1, which gives I1 is equal to E1 minus V divided by R1. Similarly, I2 is equal to E2 minus V divided by R2. Then if you simplify, that is the above equation I is equal to I1 and I2, then I am getting the value that is equal to E1 minus V divided by R1 plus E2 minus V divided by R2. Further simplified, we get the value V1 by R1 plus E2 by R1. If I take a minus V volts common factor, then it becomes 1 by R1 plus 1 by R2. Further simplify, I get, now I'm going to take a V is equal to, I'm going to take V is equal to, then E1 R2 plus E2 R1 divided by R1 plus R2 minus I1 IR1 into R2 divided by R1 plus R2. Then comparing with this equation, then we'll get V is equal to E equivalent minus I reached. Then E equivalent is equal to E1 R2 plus E2 R1 divided by R1 plus R2. Then gives this the final, that is R equivalent, that is resistance equivalent, is equal to R1 R2 divided by R1 plus R2. Two identical cells of EMF 1.5 volts and internal resistance R are each connected in parallel, providing a supply to an external circuit consisting of two resistance of 17 ohms, each joined in parallel. A very high resistance voltmeter reads the terminal voltage of the cell to be 1.4 volts. Calculate the internal resistance of each cell. Okay, so here we have the diagram. That means this is the resistance 17 ohms are connected in the parallel and 1.5 volts, and this is the R2. Then we can say that I is equal to, we know that I is equal to V divided by R equivalent. This R equivalent is given by the 17 ohms. Since it is connected in the parallel, then R by 2 we need to take. Then that is equal to 1.4 divided by 17 by 2 is nothing but 8.5 amps. Then, and V is equal to E equivalent minus I required. Then there is nothing but 1.4 is equal to 1.5 minus 1.4 divided by 8.5 times R by 2. Then R is equal to 1.21 ohms.